Welcome to our comprehensive guide on Plotly interview questions focused on interactive data visualization. Plotly is a powerful library that enables developers to create dynamic, web-based visualizations and analytical applications. In this tutorial, we'll cover the essential concepts you need to master for your interviews, including interactive plots that respond to user input and dashboards that provide comprehensive data insights. These skills are highly sought after in today's data-driven job market, making Plotly proficiency a valuable asset for any data professional. Plotly is an open-source Python library designed for creating interactive, publication-quality visualizations and web-based analytical applications. Unlike static plotting libraries, Plotly specializes in building graphics that users can interact with directly in their web browsers. The library provides built-in hover functionality that displays detailed information when users move their mouse over data points. It also includes zoom and pan capabilities, allowing users to explore datasets in detail. Additionally, Plotly visualizations can be easily exported to HTML format and embedded directly into web applications, making them perfect for sharing insights with stakeholders who need interactive data exploration tools. Plotly Express provides a simple interface for creating the most common chart types used in data visualization. Line charts are perfect for showing trends over time and are created using the px.line function with your data frame and x, y parameters. Bar charts display categorical data comparisons and use px.bar with similar parameters. Scatter plots reveal relationships between two continuous variables using px.scatter. For examining data distributions, histograms are created with px.histogram, requiring only the x parameter. Pie charts show proportional data using px.pie with names and values parameters. Finally, heat maps visualize correlation matrices and two-dimensional data using px.imshow. Each of these chart types automatically includes interactive features like hover tooltips and zoom capabilities. Plotly's strength lies in its built-in interactive capabilities that make data exploration intuitive and engaging. Every Plotly chart automatically includes hover tooltips that display detailed information about data points when users move their cursor over them. Users can zoom into specific areas of interest and pan across large datasets without losing context. Clicking on data points allows for selection and highlighting, while legend items can be toggled on and off to focus on specific data series. Beyond these basic interactions, Plotly supports advanced controls like drop-down menus for filtering data categories, range sliders for time series navigation, and animation frames that can show data changes over time. Custom button controls can be added to trigger specific actions or view changes, making dashboards highly interactive and user-friendly. Creating interactive plots with Plotly Express is straightforward and requires just a few lines of code. Let's examine two common examples. For a line chart, you start by importing Plotly Express as px, then load your sample data using px.data.iris. Create the interactive line plot by calling px.line, passing your data frame along with x equals sepal_length, y equals sepal_width, and color equals species for categorical grouping. Finally, call fig.show to display the interactive chart. Similarly, for scatter plots, you import the same libraries and load sample data like px.data.tips. Create the scatter plot using px.scatter with x equals total_bill, y equals tip, color equals day for grouping, and size equals size for proportional point sizing. Both examples result in fully interactive visualizations with hover information, zoom capabilities, and legend controls. Plotly provides extensive customization options to enhance both the appearance and functionality of your interactive visualizations. Layout customization is achieved through the update_layout method, where you can set custom titles, axis labels, and apply different themes like Plotly_dark for better visual appeal. The update_traces method allows you to modify hover templates to show specific information when users interact with data points. For styling, you can customize colors by setting marker_color to specific values or use color scales like Verities for continuous data mapping. You can also adjust marker sizes, line styles, and transparency levels. These customization options ensure that your visualizations not only provide interactivity, but also maintain professional appearance and deliver the exact user experience you want to create. Plotly Dash is a Python framework specifically designed for building interactive web applications and analytical dashboards. Unlike simple plotting libraries, Dash enables you to create complete web-based applications using only Python, without requiring knowledge of HTML, CSS, or JavaScript. Dash combines the visualization power of Plotly with interactive web components to create sophisticated data applications. The framework is built on top of Flask for web serving, Plotly.js for interactive graphics, and React.js for user interface components. Key features include pure Python development, meaning you can build entire web applications using familiar Python syntax. It includes an interactive callback system that allows components to communicate with each other and respond to user actions. Dash also supports real-time data updates, making it perfect for live dashboards, and offers flexible deployment options for sharing your applications globally. Every Dash application follows a consistent structure that makes development predictable and maintainable. You begin by importing the required libraries, from Dash import Dash, HTML, and DCC for core functionality, plus Plotly Express for creating charts. Next, initialize your application by creating an app variable equal to Dash with __name _ as the parameter. The app layout defines what users see on their screens and is created using html.div containing your page elements. Inside the layout, you can include headers using html.h1 with your title text, and interactive graphs using dcc.graph with an id parameter and empty figure dictionary. Finally, the application runs when you include the standard Python conditional if __name _ equals __main __, followed by app.run with debug equals true for development mode. This structure provides the foundation for any Dash application, from simple charts to complex analytical dashboards. Dash applications are built using two main categories of components that provide both structure and interactivity. HTML components mirror standard web elements and include html.div for creating container elements that group other components together. HTML.h1 through h6 create headers and titles of various sizes, while HTML.p generates paragraph text for descriptions and explanations. HTML.br creates line breaks for spacing control. Core components provide the interactive functionality that makes Dash powerful. DCC.graph creates interactive charts and visualizations that users can explore. DCC.dropdown generates selection menus that allow users to filter or change data views. DCC.slider creates range controls for adjusting numeric parameters, and DCC.input provides text input fields for user data entry. These components work together to create intuitive user interfaces where users can interact with data through familiar web elements while viewing dynamic, responsive visualizations. Building interactive dashboards requires combining layout components with user controls to create responsive data applications. A typical dashboard layout starts with html.div as the main container, followed by html.h1 for the dashboard title. Interactive controls like dcc.dropdown allow users to filter data by categories. For example, you might create a dropdown with id equals category-dropdown, containing options for different data categories like sales and revenue, with a default value of sales. The main visualization is created using dcc.graph with a unique id like main-chart. This structure enables the dashboard to respond to user selections and update visualizations accordingly. The combination of these components creates a professional, interactive interface where users can explore data through drop-down selections, view updated charts instantly, and gain insights through dynamic data visualization. This approach makes complex datasets accessible and engaging for end users.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.